So now we want to start writing our formulas and start doing our naming. But before we can do our formula, we have to understand why certain atoms are going to bond with other atoms. And so to be able to kind of visually see this, we're going to start drawing Lewis symbols. Now, Lewis symbols also have another name. They're called electron dot symbols. And these are going to help us to visually represent what's going on. So the way that we draw these is we write the symbol of the element, and this represents the nucleus and all the inner electrons. So all those core electrons. So remember we talked about core electrons when we talked about our effective nuclear charge and our shielding. We're going to use dots placed around the symbol to represent our valence electrons, because our valence electrons are going to be the ones that are going to actually make bonds and do stuff. So we just really care about the valence electrons. Alright, now remember when we draw our dots that the first two electrons are going to be in the s orbital, and then we draw each electron by itself at first to represent those p orbitals, those p electrons. So think about the electron configuration. We're in essence taking the electron configuration, if you were to write the shorthand, and all of those electrons that would be after the noble gas, now we're drawing a picture of them. Alright, so lithium is in group 1, and so he would have, it would be helium 2s1. Okay? So if we said helium 2s1, he's got one s electron. So the way we would draw his Lewis dot picture is we would write a symbol, and here's one dot. This dot is that s electron. Okay? For beryllium, it's just 2s2. So he has two electrons in the s orbital together. So you would write the symbol and you put the two dots to represent the two electrons in the 2s. Boron's 2s2, 2p1. Okay? So we've got the right boron and then the two s electrons and then the p electron by itself. Carbon is 2s2, 2p2. So you've got the two electrons that are together, but we don't put the two p's together. Because remember when we're doing a p, we've got the p, we go up, 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 then down, down, down. So these two p electrons are not together. So that's why we have one pair and two by themselves. Then nitrogen has three p's. So you've got the two s electrons and then the three p's by themselves. Oxygen has four p's. So now you've got three up and then you've got one pair. So you've got your s pair, your p pair, and then you've got two by themselves. F, you've got two. You've got a pair here for your s, and then you've got your two pairs from your p and the one guy by himself. And then if he's neon, he's completely full, so you've got your s and then your 3p pairs. Okay? So now you can do it for any valence electrons. If you've got one valence, 2, 3, 4, 5. So this is for 1, 2, 3, 4, 5, 6, 7, and 8. The only difference would be if you just have to change the element symbol in the middle. Okay? So we'll talk about this a lot more. This is just a little intro. Okay? So now let's talk about what's happening if I make an ion. So this is if it's just neutral. So if I'm making an ion, then how does my Lewis picture change? So if I'm making a cation, so remember if it's a cation, I'm going to lose some electrons. And so if I'm making a cation, here would be my neutral lithium, so this is just Li. So if I'm going to lose, this electron goes away. So it would just be Li. But I don't want to write just Li, I want to notate that it was changed to an ion. So it's Li plus. So this is kind of what you're used to writing. So when you wrote Li plus, plus 1, you didn't realize you were writing its Lewis symbol. Okay? So you just take whatever the neutral picture was and then remove however many electrons, and it's just the symbol plus its new charge. Anions, they're going to gain electrons. So here, this was fluorine. He had 7 electrons. He's going to gain 1 electron. So this is its new electron, went right here in this empty spot. Okay, so he gains 1 electron, and to notate, we just put a box around him and put a -1. And we want to put the box around him because later on we're actually going to put charges like on the elements themselves versus the whole thing. So we want to say that the whole thing is a -1. So that's how you write the Lewis pictures for anions and cations. Alright, so on the next lecture, I want to talk about now these are just elements. So this would be if it's a pure neutral element, and now we talked about the Lewis symbols for if it's a cation or an anion. Now what we want to talk about is what happens if 2 of my elements end up trying to make a bond. And specifically, we want to talk about ionic bonds in this lecture.